And the TD working group under WMO is now working for developing new method for the generation of advanced probabilistic warning for high impact weather events, such as those associated with tropical cyclone and heavy precipitations. And new project will demonstrate the feasibility of the TD ensemble dataset. The homepage will open soon. Okay, thank you very much.
Okay, question.
Questions? Yes, Johnny. Professor Chen. Dean.
Thanks, Russ. I have two questions. The first one is for NAKAZAWA-san. If you look at the tracks of JMA versus ECMWF, do you think it has anything to do with the representation of topography in the model?
Yeah, I haven't checked the topography, but definitely it looks like maybe more final scale in ECMWF rather than the GMA. So maybe some
Finer topography, you mean?
Pardon?
Finer topography.
Yeah.
But do you think this is if you look at other situations like other storms that hit Taiwan, do you see similar type of differences in terms of the tracks?
I haven't checked yet, but maybe not so much influenced by the topography because at the initial stage in August 5th, very far away from the coast of east coast of Taiwan, but still we have a tendency to move northward. So that's why I'm not sure.
I really think it was too big a storm. I mean, if that was the representative one, he had a huge vortex. Our JMA did not. I didn't blame him.
The second question is more towards Russ about your talk related to the prediction of precipitation. You mentioned one of the possibilities is what Barbara Brown suggested is to look at the identified objects to verify. But if you look at JMA's forecast of the precipitation, I mean the pattern, the bulk of precipitation looks pretty good. It's just in the wrong location.
Yeah.
So if you use the method that Barbara suggested, then I'm sure that the forecaster is not going to use it after a while because they will say that what good does it do to me in the forecast because it's one is in southern Taiwan and the other one is in northern Taiwan. So it's the example that NAKAZAWA showed is actually against what you suggested or Barbara suggested in terms of verification of the precipitation.
I'm going to let Rob answer that because he's dealing with that on a daily basis.
Yeah, I think what Russ showed with respect to Barb's suggestion for sort of track, and it's the stuff that Tim Archok and I published a paper on as well, kind of a track relative verification of structures in the precipitation field. From a forecasting perspective, I agree with you, Johnny, that I don't think it's necessarily that applicable because if the track is going to be to the south, it's going to have a significantly different distribution, obviously, than the north. But in terms of a storm relative verification, I think that's more relevant for model evaluation and model diagnostics and model development. And in that sense, it allows you to, at least the hypothesis would be, it allows you to extract out that track error signal and really just focus on the structural based errors in the model and things like parameterization scheme development and testing and those types of things. I think that sort of verification methodology is more of a diagnostic methodology as far as model development.
Yeah, I agree that the intensity forecasting is really important, but at the same time as you mentioned, track forecast is also comparably important. Otherwise, we cannot get the right answer of the precipitation.
One of the things I noticed there in your JMA Typhoon ensemble prediction system, the tracks were very similar to your weekly model,
but the intensity is different.
Intensity is different?
Yeah, because it's based on the singular vector analysis and especially over tropics. But the weekly ensemble doesn't include any SV method to initialize.
And when you mean weekly, you mean once a week you run that?
No, Typhoon ensemble forecast runs every 6 hours.
Yes, but the weekly one?
Weekly one, once a day.
Numbers.
Once a day.
Oh, once a day?
Yeah.
To a week? Why do you call it weekly?
Oh, up to weekly. Up
okay.
to 9 days or 10 days.
10 days.
Yeah.
Yes.
For the JMA ensemble systems, I think the big difference is on the intensity. So I would like to ask you, what is the reason for the difference? Is because of the difference in the initial condition perturbation, or the physics different, or initial structure of the vortex different?
Initial condition.
Initial condition.
Initial perturbation.
Okay, so it's a random perturbation, or
No. It's a SV, singular vector.
Okay, another comment I would make, I think you showed a very important result, and I'll ask Sim Averson if he believes this is a general result. What he showed was that by making observations only in the sensitivity area, you could get the same effect as over the whole area. That's very important for Frank Wu, who's going to talk later, where they have only one jet. They don't have 3 aircraft to do this. And so, Sim, where are you? Sim, do you think that's a general result?
Sim's the expert in the Atlantic.
I think it depends on the data assimilation system that you use. As you get to more advanced data assimilation, more data are going to help. With the old 3D VAR that we had, the SSI in the Atlantic, removing the data outside of the sensitive regions actually helped the forecast. I don't think that's going to be the case with 4D VAR or ensemble Kelvin filter. But even with more advanced techniques, we're showing that outside of the sensitive regions, the data aren't as important as they are inside the sensitive regions.
Yeah, it seemed to me much more difficult issues on data simulations. I didn't show up, but the data simulation, it depends on the models and centers and differs the result largely.
I also wanted to, in the beginning of your talk, you gave 3 possibilities of having the, an ensemble plus high-resolution regional forecast. I'd like to offer a 4th possibility that's my preference, and that's a global ensemble forecast plus a regional ensemble forecast.
Okay.
And we're doing that because we're going to ensemble-based data assimilation of the regional forecast, and with that you have to have an ensemble forecast. So we'll have ensemble forecasts on multiple scales, and that would be a very good thing to have, I think.
Okay, I will include the 4th one, blanket sim.
We'll have that this summer in the Atlantic.
Okay, thanks.
Okay, one final question. Are you getting hungry? Okay, I saw those hungry faces out there. Okay, I'd like to thank all the speakers this morning, and I think turn it over to